Welcome everyone. Today we have the lecture of the structural concrete design one. So we will continue with the moment and shear lecture, which is simplified method to calculate moment and shear. I will share the screen.
Yes.
Okay. So here we have I think you have this lecture in the Moodle. You can download it in the Moodle. So simplified method of analysis for non-pre-stressed continuous beams and one-way slabs in the ACI code, the section 6.5. So here we have the approximate moment and shears. So give reasonable values for the stated conditions. In the strength of materials, I think you studied this one. So for example, if we have, this is simply supported. So this is the roller. So this is, for example, distributed load. What is the moment for this one? The moment is equal to WL square over 8, right? So this is the moment. So, and the shape of this moment, it will be like this. It will be like this. Okay, pause it. And the shear diagram for this one, it will be like this one. Okay, this is positive and this is negative. This is shear force diagram. This is bending moment diagram. Okay, and the area of this one, it's representing, this is the area. Okay, this is the value of this one, and minus this value, so we go back to the zero value. So here in our lecture, we will learn if we have continuous frame. Okay, so here we have the beams. If we have the continuous beams and one-way slabs are the part of the frame or continuous construction because of the load pattern that produce critical values for movements in columns of frames differ from those for maximum negative moments in beams. Column movements should be evaluated separately. So here the approximate method assumes that the members are prismatic. So we have no change. So this is the prismatic section. Okay, for example, we have 30 centimeter, 50 centimeter. Okay, we don't have like this one. Okay, like this one, the non-prismatic. This is the non-prismatic one. Okay, so we have the prismatic, the load are uniformly distributed. So we have distributed load and we have the limitation live load smaller than or equal to 3. And we have the dead load. This is the live load over the dead load. So it is smaller than or equal to 3. This is important. Okay, so this is live load over live load should be smaller than or equal to 3 dead load, or we can say it as live load or over dead load smaller than or equal to 3. So here there are two list spans. For example, here we have, this is the first span, this is the second span, okay? Or maybe we have fixed, we have the two spans here. So this is the first span number 1, span number 2, or maybe we have more than 2 span, maybe 3, 4, 5, okay? So, and we have the longer of two adjustment span does not exceed the shorter by more than 20. So this is the percentage. So long span, for example, here we have this span 4 meter. This span is 4 meter. So this is span number 1, 4 meter. Span number 2, 3 meter. Okay. span number 2, 3 meter. So what's the difference between this one and so we can say 4 minus 3 over the short span. Which one is the short? It is the 3. So is equal to 1 over 3 is equal to about 0.66, okay, which times 100 times 100, so is equal to so 1 over 3. Let me show you this. Okay, this one 1 over 3. It is 0.33. I'm sorry, 0.33, not 0.66. It is 0.33. So 1 over 3 is equal to 0.333. So times the 100%. So is equal to 33.3%. Okay. So this is not allowed. This is not allowed. Why? Because it is greater than 20%. So what about if we have 3? If we have 3.3, okay, so we have two span. What's the difference between them? It is 3 minus 3.3, it's 0.3 over 3 is equal to, so we can use our calculator here. So we can say like this, 0.3 divided by 3 times 100, it is equal to 10%. Okay.
10%.
Okay, so this is the perfect one. Okay, so now I think you understand now what is the difference between two spans, adjacent span. For example, 3.3. And for example,
دكتور
بله إبراهيم فرمو
دكتور
بله
دكتور ئەم من موبایلم نازم زۆر گرم داتێت دەنگەکە زۆر بە خراپی دێ دەسمە درێ و دێمونە بزان باش نابی.
Okay, no problem.
Okay.
Bash.
See you.
Okay, so 3.3, we have 4 meter here. So for example, what's the difference? We should take the two adjacent spans. For example, 3.3 and 4 meter. So 4 minus 3.3
0.3.
divided by 3.3. Okay, so and what's the value now? So go to the 4 minus 3.3 divided by 3.3 times 100. So it is 21. It is not allowed. Okay, so we should apply for the adjacent two spans. So it should be smaller than the difference 20%. Okay, so this is the table in the ACI 6.5.2. Now we have the moment NU due to gravity loads shall be calculated in accordance to this code, ACI. So here we have the continuous beams and one-way slabs. If we have positive and negative, what's meaning negative, what's meaning positive? For example, here we have support, here we have support, for example, here we have support. At the support, we have the negative moments, okay? At the support, we have negative moments. At the middle, at this part, we have positive. Here we have positive, okay? For example, here we have like this, okay? It will be like this. Okay, here we have 0 because it is the hinge. Okay, here we have negative moment, positive moment, negative moment, positive moment, and here we have 0. Okay, but if we continue this one, so it will be negative. Okay, here we have 0. Now, if we have now spans. So what about positive one? Okay, so here we have the location is discontinuous and integral with the support. Okay, and this is the end one, and we have also interior spans. Now discontinuous and integral with support. So we have WL squared over 14. We have also discontinuous and restrained. We have WL squared over 11. I will show you in details what's meaning these values, okay? In the interior, we have WL squared over 16, okay? And here we have the negative one. We have the negative interior face of exterior support. We have WL squared over 24 member built integrally with support column WL squared over 16. If we have exterior face of first span, so it will be 2 spans WL squared over 9. If we have more than 2 spans, will be WL squared over 10. Here we have WL squared over 11. So face of other supports, face all support satisfying slabs with span not exceed 3 meters. So beam where ratio of sum of column stiffness to beam stiffness exceeds 8 at each end of spans. So it will be WL squared over 12. So here, what's meaning LN? LN here, when we say LN, it is the average of adjacent clear span of 2 span. So for example, we have 3, we have 3.3. So the adjacent between them is 3 plus 3.3 over 2. It will be LN, but should be clear, not center, okay, of the support. So we will take the example to show you. So, and also we have the shear here. So we have exterior face of first interior support 1.15 WULN over 2. So F face of all other support WULN over 2. Now, we have end reactions to supporting beam. For example, here we have a column, we have beam integrated, okay? So here we have the wall, and here we have beam or girder, so masonry. And here we have the spandrel beam, okay? So this is the slab or beam or girder, and we have the end of the column. So this is the spandrel beam. Now, reaction to support beam, column, or wall are obtained as the sum of shear forces acting on sides of the support. Integral and unrestrained support are illustrated in this one, figure 1. Exterior and interior support are shown in figure 2. So here we have figure 1, okay, as for example, beam girders directly goes with the connected with the column, like the flat maybe girder, like the here we have integration between them. So we have the beam or girder in this region. So here we have the beam continuous in this region. Okay, it will be as the spandrel. Here we have beam or girder inside the wall. So this is the important figure. This one, exterior support, first interior support. This is the interior support. Here we have exterior face. Here we have the interior face, because here we have the interior region here. Here we have L1 prime, which is the length of the first span. This is the length of the second span. So here we will have, for example, in the interior beams, so here we have the A steel, and this is the height, okay, the total height, and this is the D, okay, from the top of the slab to the middle of the A steel, it is D, and this is the height of the floor, HF, okay? So here we have, for example, I think in this example, you will understand carefully. So here we have restraint, okay, restraint. For example, we have column integral with support. We have 1, 2, 3. We have here 3 spans. Here we have 2 or more span prismatic. So uniform distributed load WU, which is L live load over dead load, smaller than or equal to 3. And here we have the wall unrestrained, okay? So here we have the, like the hinge, the moment is equal to 0, okay? So here we have the Ln of 2, okay, and we have Ln1, and here we have 1.2 Ln of 2. So here Ln1, okay, the Ln1, which is the length of the span 1, it is greater than Ln over 2, greater than this one, but smaller than or equal to 20%. We say 20%, which is 1.2, okay? Well, maximum 1.2 Ln2, this one. It's maybe this Ln greater than this one, 1 Ln2, but should be smaller than 1.2 Ln2. Okay, you can say the two adjacent, the larger one minus smaller one divided by the shorter one or the smaller one, so should be smaller than or equal to 20%. You can do like this. So we have Ln2 here. So what's the positive moment? What's the positive moment? WLN1, this is Ln1, this span, this one, this is the Ln1, this is Ln1, okay? So this is the positive moment, M positive, okay, at the middle here in this part. While here we will have the negative. Also here we have the negative. So the negative one, a spandrel support, it is WLN square over 24, okay? And here in this phase, we will have WLN square average. Why average? Because here we say that if we have two span different, we should take the average, okay? This Ln1 plus Ln2 over 2, okay? So if for example, if this one 3, so 3 plus 3, 6 over 2, 3. So it will be 3. If we have, for example, 3 and 3.3, it will be 3 plus 3.3 over 2. Okay, like this. Here we have the positive moment here. This is the positive moment. And here, this is the positive moment here. What about the negative one? This is the negative one, WL squared of which is the average. We say we take the average over 11. Here we have the WL squared over 11. Here we have this dimension, which is the Ln2. It is the same of this one. For example, 4, 4, 3, 3. It's the same. Okay, we have at the face here WLN square over 10 at the exterior face. This is negative. And here we have 0, we say. This is if we have spandrel support, like the beam. What about if we have column? If we have column, it will be WLN squared over 16, okay? But, and we have the same of this one, the same of this one, the same of this one. So here we have the note A. We will go, what's meaning the note A, okay? What meaning the note A, which is WL squared over 12, WL squared over 12, WL squared over 12, WL squared over 12, and WL squared over 12, 0. Now, if we go back to our, here, let me show you into, this one, this is the positive, WL squared over 14. WL squared over 14 positive. Is it clear this one? WL squared over 14. Where does it come from? This is WL squared. This is the positive moment. WL squared over 14 in the end span. What about the interior one? If we have discontinuous and unrestrained, WL squared over 11. So this one, WL squared over 11, discontinuous. Okay, it's in. يعني خلاص دبيتن. كوتاي بيديتن. Okay. What about interior? What about the other one, interior stance? So it is WL squared over 16. So here we have WL squared over 16. Okay, interior. So, and now we learned that the positive moment, WL squared over 14 in the end span in discontinuous and integral with the support. Here, integral with the support. This one, integral with the support. This one, okay? Starting one. And we have this is very important table. We have this continuous in and unrestrained. We have this is unrestrained hinge. Okay, WL squared over 11. Now, what about the interior spans? It is WL squared over 16. Okay, this is the positive moment. Okay, what about the negative moment? Now, we have interior face of exterior support. This is the interior face. This is the interior face. This one is interior face. This is the interior face. Okay, so it is WL squared over 11. So here we have WL squared. Where is the interior face? Member built integrally with the supporting spandrel beam. If we have spandrel beam, it will WL squared over 24. Okay. If we have member built integrally with supporting column, it will be 16. Exterior face, if we have two span, WL squared over 9. If we have more than two span, WL squared over 10. And face of other supports, it's WL squared over 11. Okay, so here we have unrestrained. So here we have, for example, the -1 over 10. This is over 10, which is it is in the exterior span, WL squared over 10, WL squared over 10. Okay, so this one, exterior face of first interior span. Exterior face, this is very important. Exterior face of first interior span. Okay, it is more than two span. Yes, we have more than two span. So we have WL squared over 10. This is the exterior face of first. This one. This one, it is the more than two span. Yes, we have, this is the exterior. The first one, it will be WL squared over 10. More than two span. Exterior face of first interior support. Yes, this is first interior support. This is the first interior support. So this is WL squared over 10. Now, go to the interior one. Okay, we have spandrel support. We have spandrel support. Now, face of other supports. Okay, face of other supports. All WL squared over 11. WL squared over 11 other supports. And here also we have that first one, WL squared over 10. Okay, we have more than two spans, exterior face of first interior spans. Okay, it is the same two span. We have also WL squared over 10. Now, this is in case if we have spandrel. What about if we have column support? We say that if we have column support, here, member built integrally with supporting column. This is column support. WL squared over 16
دكتور.
in
دكتور بزرقوا مشان نادا
مشان هذا
بلا استلعي من الرويشت
Esta Roy?
بلا
Esta?
بس شاشة لابتوبيا بس
نا دكتور سكرين شيرەکەی هەیە
أو إيمانية أو سكرين شير كرديتي سكرين شير طلبة كرديتي أو إيمانية أو سكرين شير دكتور استعمل أو أوكي
استهاتو دكتور طه
زانم قوتابیان تکایە دەستکاری مەکەنەوە باشە ئەمە لێرە شتەیە قەپاتم نەکردیان شێر سیتینگ یعنی ئێستا دەبێت بە خۆم قفل کەم تەنها بەس لەو خۆم بیتن اوكي current size advanced sharing enable remote auto fence اوكي با use send اوكي با يعني تکایە دەستکاری مەکەنەوە باش قساوەکەم با بینە سەر سکرین شێرەکەمە نازانم ئێستا دیارە
بله
okay this is very important please spandrel WL square over 24. WL square over 24. If we have spandrel spandrel beam, negative spandrel beam, WL square over 24. If we have column depth WL square over
11
16.
Fazla.
16.
شاذ.
This is 16. Okay, column, this one. 16, column, 16, spandrel beam, WL square over 24. Okay, so this is not A. This is not a phase of all supports that span A or B. Slabs with spans not exceed 3 meters. If we have, for example, slabs or spans not exceed 3 meters, for example, 2.5 or 3 beams where ratio of some column stiffness to beam stiffness exceeds 8 at each end of spans, okay, it will be high. This one, okay, WL square over 12, WL square over 12, WL square over 12, WL square over, all WL square over 12. This is the special case. This one special case. It is rarely to be used. Okay, rarely to be used. This one. Okay. And we have the negative. Here we have the negative. It's the same negative here, same negative. WL square over 11, WL square over 11, WL square over 10. Here we have 0. So WL square over 9. This is the star. This is the star. If you see the star here, what's meaning the star? So if we have 2 span only, so we should say this is WL square over 9. Okay. If we have more than 2 span, it is WL square over 10. So here, not saying we applicable to 3 meters. It's here the foot you can convert to the foot. So, and also the LN average. What's meaning LN average? It is LN1 plus LN2 over 2, the average of 2 spans. Adjust W for beams, WL square over 10. Here we have that double star. Here, what's meaning double star? We can change this one WL square over 12 to WL square over 10 for if we have the beams. Okay. So, for example, here we have unrestrained. If we have 2 span, here we have unrestrained. So, what's meaning unrestrained? Which, for example, we have columns. Okay. So, here we have if we have walls, okay, because in the walls the movement will be 0, okay. If we have column, will be negative movement. If we have unrestrained, what's meaning unrestrained? This is unrestrained. It's a wall. It's simple support. It's hinge. Unrestrained, okay. Unrestrained, it's 0 movement. So it will be 1 over 11 WL square over WL square over 11, WL square over 9, WL square over 9, WL square over 11. These just only coefficients. What about if we have spandrel, WL square over 24, like this? If we have spandrel, WL square over 24, and WL square, here we have over 14, WL square over 9, WL square over 9, WL square over 14, WL square over 24. What about if we have column? It will be negative movement at the supports, okay? Or restrained column, or restrained support. What's meaning restrained support? Okay, so here we have the WL square over 16, WL square over 14, WL square over 9, WL square over 9, WL square over 14, WL square over 16. What about unrestrained? But what's the difference between the A and B? You know what's the difference? The A is 2 span, the B is more than 2 span. So here it will be 0 like this. 1 over 11, it's the same, but here will be instead of 1 over 9, it will be 1 over 10, WL square over 10, WL square over 11, WL square over 16, WL square over 11, then WL square over 11, WL square over 16, it will be continuous like this. So, what about if we have what's the difference between C and D? C is 2 span, D is more than 2 span. WL square over 24 like this, WL square over 14, same. WL square over 10, not 9 here. WL square over 11, WL square over 16, WL square over 11, WL square over 11, WL square over 16, then it's continuous to WL square over 11, like this. So we have also column. If we have 2 span here, if we have this 3 span. I think it is clear now. And G, it is the shear force for 2 or more spans. It's WL over 2, W 1.15 WL over 2. So here we have 1.15 WL over 2. Now we have, for example, this one, WL over 2. So I will share the, here we have, here at the attendance, please fill this one as soon as possible. This is the attendance one in the chat. I'll share. So here we I think you see this forum. Okay, please fill. We have 30 participants now. Okay, let's continue. Let's continue. I think you are seeing my screen. Okay, so this one. See, yes. So here we have simplified method of analysis for non-pre-stressed continuous beam and one-way slab. Okay. So here we have column A, B, C, D, E, F, G. Column. So what is the shear force diagram? W, U, L, N over 2. Here will be 1.15 WULN over 2. Here WULN over 2, WULN over 2, 1.15 WULN over 2. So this meaning that the exterior spans, it's 1.15, while the interior spans WULN over 2, WLN over 2. And the exterior also WLN over 2. What about the bending moment diagram? In the bending moment diagram, if we have column, it will be WL squared over 16 if we have 3 spans. If we have 3 spans here, WL squared over 16, then we have WL squared over 14. This one, WL squared over 14. Then we have WL squared over 10. So this is the WL squared over 10. Then we have WL squared over 11, this one, WL squared over 11, then 16, then 11, then 16, then 11, then we have 10, 14. Here we have, so this is continuous, If we go to the last one here, if we go after, for example, 3, 4 spans, if we go last one, we can get the same. 10 will be here at the end, 14 and 16. It is symmetric. Okay, it's symmetric of the first one. It's the symmetric of the first one. For example, 14, 14, 10, 10, 16, 16. Okay, so this is the symmetry because we have column. What about spandrel beam? WLN over 2, 1.15 WLN over 2, WLN over 2, WLN over 2, 1.15 WLN over 2, and WLN over 2. So, bending moment diagram, what about if we have spandrel? Go to the spandrel, or we can make like this. Okay, like this. Let me copy this one here. Like this to compare. Okay, for example, comparing. What about if we have spandrel? Okay, this is the spandrel one. So we have ln over WLN square over 24. Then we have 14. This is 14. We have 10. Okay, we have 10. Then we have 11. WL square over 11. Then we have 16, WL square over 16, WL square over 16. Then we have 11. So continuous. Now we have symmetric. So WL square over 14, 24, 10. Okay. So what about if we have unrestrained and unrestrained and like the brick wall? So it will be the same shear. It is not changing the shear. So just only changing in the bending moment diagram. 0, 0. So we have 0, 0. Let me, okay, converge to this one. So here we have spandrel one. So please enter the Zoom using the same link. So W, here we have spandrel, unrestrained, this 0, WLN square over 11. Okay, this one, WLN square over 10, WLN